Hi. Hello, everyone. Thanks for coming. Last big technical talk of the day before the keynote. Hope you still have some energy. I took my coffee to appease the demo gods. Hi, I'm Daniel. So as T said, I work for VMware. I work in the Spring teams, and I work in the Tanzu group on the Tanzu application platform, which is VMware's platform for deploying apps on top of Kubernetes. And in that group, I work on the SSO component, right? So if your app needs SSO in front of it, then you'd be using my component. Here are my socials, website, email. Reach out. It's always a pleasure. I take the time to answer because I'm not flooded with email, maybe not within the week, but go ahead and we'll have lovely discussions. If you're not shy, come to me at the after party to discuss about this. So before we get into the deep of it, a few disclaimers. This is an overview, because Carvel has 7 tools. And out of these 7 tools, if I take 5 minutes per tool, you do the math, it's almost the entire talk, right? So we're going to go over a few things. And it's going to go fast, because I have too much content. It's not because I had too much coffee, it's the content. I don't expect you to remember every command that I type in my demo, but I want to inspire you a little bit and show you what's possible. And lastly, what's important to tell you here is that I'm an app developer. I mostly write Java for a living. I know, dirty. Don't judge me, all right? Not an operator persona, so I don't live in the world of GitOps and Helm and so on. So I cannot answer a pointed question of like, but how does this integrate with Argo CD, or like, what's this compared in this complicated workflow with Helm? So pardon me, you'll have to find that by yourself. All right, so what are we going to be talking about today? Carvel. A few words in what this is, and then we go into the demo. I have a toy application that we can build, deploy, manage with the Carvel tool suite. So Carvel is a CNCF sandbox project. It's been sandboxed in September 2022, so 1 year. Happy birthday, Carvel. And on the website, it says Carvel is a suite of tools that are reliable, single-purpose, and composable, and they allow you to make some YAML and push that YAML to a Kubernetes cluster, basically. So reliable, most tools will strive to be reliable, so I won't comment on that. Single purpose, that's one of the interesting characteristics of Carvel. It's not like Helm, which has one big solution to solve multiple problems. Carvel decides to chop it up. This defines small problems and make one tool. So one tool for templating, one tool for deployment, one tool for resolving images, and so on. Right? And the idea is that still it provides a complete solution. So opposed to maybe Kustomize, right? It goes all the way to deployment, and the idea is that they work well together. You can take one tool and run with it and then put that in your workflow, or you can take the whole suite and then compose it with Unix pipes or steps, whatever. You can find the tools at carvel.dev. So let's open this website. Here are the 7 tools of Carvel. We're not going to go over vendor today, which is a thing where you declare some dependencies. You say they live in Git. These files, they live in Git. These files, they live over HTTP. And then you can lock a certain version and vendor sync and download them, right? There's also a secret gen controller, handy controller for generating secrets. So you have resources that say, I want a certificate, I want an RSA key, I want a password, and it will do that for you. We can also copy secrets between namespaces and so on. But we won't go into those 2 tools. We'll look at the other ones. So the first tool that we're going to see is YTT. And what's the excuse for using YTT is we're going to deploy a very simple application. It's an Nginx deployment that exposes one HTML page stored in a config map, and it's exposed with a service and an ingress, right? So 4 resources. But we want to do this for each of these fruits, apples, bananas, and strawberries, right? So 3 times 4. So 3 times, we have a for loop in here. And this is where YTT comes in handy. So YTT is a YAML templating tool, and it's Kubernetes agnostic, YAML aware, and you can template and patch YAML with this. So YAML aware as in, it's not a text templating tool. It's made for templating YAML. So if I pass it wrong YAML, it yells at me. It's Kubernetes agnostic, as I can template any YAML with it. So if you have GitOps actions that are complicated, then you want to template them, you can use YTT for that. It's not just Kubernetes, even though the demo is this. And so first, let's do the thing where we generate our config maps and services and deployment and so on. So we're going to start by writing a YAML file, app.yaml, foobar, whatever. And in here, I'm going to pass this to YTT. So maybe file, application, app, not values, app.yaml. Have I saved this? No. App.yaml, right? And it just spits the same file back, which is normal. So to iterate over this, what I'm going to do is I'm going to watch it. And when it changes, I want to run this command. So I'm going to run clear to clear my terminal. And I'm going to run YTT and F on it, right? Application, app.yaml. So every time, hopefully, every time I change my file, it's here. And so now we can start building something with it. OK, so we said we want config maps. API version, v1, the kind is config map. It has metadata, of course, name. I'm going to start with fruit, whatever. Namespace, default. Don't do that, of course. And then it has data, index.html. And then we can say hello world in it, whatever. OK, so it gets updated here. OK, this is not YTT specific. It's just YAML. Now I want to do my for loop. How do I do this? The control flow and all the YTT programming happens in comments. So my document is still a valid YAML document. I'm going to do this here, and I'm going to start with a for loop. So for app in apples, bananas, and what was the last one? Strawberries. Strawberries. For each of these, I'm just going to do the same config map, right? And then in here, close the for loop, and now I have 3 config maps, 3 times the same. So here I've defined a variable, right? App, so I can use it. This is going to be the name of my config map. App, and then here I can do text templating if I want. So hello, and then format. I'm going to use app, right? So now I have 3 config maps, and they have the right name, and they have the right message. So let's look at this YAML a little bit and these comments. I'm going to turn syntax highlighting on, because I like pretty colors. So anyone here writes Python? Yeah, right? Recognize Python? So this is not strict Python, but it's Starlark, a dialect of Python. And it doesn't have indentation. But this is still a valid YAML document, right? If I feed this into YQ is not going to explode. So I said it's YAML aware, so if I try and do like, you see here, I make bad YAML like this. Whoop, if I manage, right? YTT is unhappy, right? Because this is not valid YAML. And as you've seen before, it's not Kubernetes specific. OK, I can make functions as well. So let's take this. We're going to create a function. So config map, for example, app, content. And then here, I close my function, end. And in here, this is going to be content, right? And then I can call a function. So make me a document for every one of these apps. Call the function called config map with app, and then with the content, right? There you go. So nothing changes on the right, because it's still the same program, but with a function. Sound good? All right. So we have our 3 config maps. We can do control flows. We can do functions. But then what if my fruits here, I want them to come from the outside? I want those to be templated in by the user, not by my program itself. In here, I have a values file. So it's a special YTT file that starts with a comment, tells it these are data values. And I can define any YAML content that I want. So it's very similar to Helm values, right? So I have strawberries, it has HTML, bananas, and so on. So we can do the same templating here. But instead of just passing app, I could pass application, etc. values, or I can pass the entire directory. So this one will take my data values files with it. So in here, if I go back to the values, if I remove the comment, this is a YAML file. So YTT is, I have to watch the full directory for seeing updates. So YTT adds the document, right? It's like, yeah, you pass me YAML, I give you YAML. OK, but if I say it's data values, it ignores it. It treats it specially. So we can go back into our app, and we can use it. In here, we're going to load a module, a YTT module called data to interact with data values. And so in here, instead of loading the app from hard-coded, I can do, this is from apps, and so app, I'm going to use app.name because it's a YAML map, and then here I think it's called app.html. So here it changes a little bit on the right because it uses values that are templated from this data values file. As a user, I can pass it any other value, so either with a command line flag, so I can do dash dash data value, or I can even pass it a YAML file and tell it, this is my data values file. So maybe let's take a look at it first. My custom values. So here's more HTML-like content. And I can tell it, well, also ingest that, that data values file here, other resource, my custom values. And then here you see the same output, but it's taking it from outside. Now, there's one last file in this directory, which is the values schema. I can define the schema for my values, which is you can only pass apps, and it must be an array which has elements with name, HTML, and public. So if I try and do my YTT command here on the right, and I do data value foo.bar equals 42, YTT is unhappy. It says, well, you passed me a foo, but I only expected apps. Similarly, it has public true here, right? So if I go and change my other values, and it knows to expect a Boolean. If I pass a non-Boolean, then YTT is unhappy. It says, well, in your value schemas on line 6 here, you said this is a Boolean. Why are you passing me a integer? Right? OK. So we have our config maps. Maybe you don't want to spend an hour watching me writing services and ingresses and so on. So maybe we cheat a bit and we do a thing where we have the full template. So application app, right? So it's the same, but this time I also have resources, the deployment, the service, the ingress, and I do my for loop, and then I paste I call my functions. So I could apply this application app, and then I could do, I need the values, or I don't need to, but I can. Other values, my resource. And then if I want to apply it, I could take this and kubectl apply f dash, right? And then it applies it to the cluster. Not dash f, my bad. Data values file. It applies it to a cluster, right? And then I don't have immediate feedback. I have to go and look at my cluster, look at the deployment, see that they're running. They are running. I can go in the browser and see them, right? They're here. Fine. But I would like to have a little bit more power to maybe not have to write my own kubectl wait rules. So the second tool in the Carvel toolbox is called cap. Cap is a replacement for kubectl, and it has the concept of an app. So the idea is you pass it a bunch of files. It reads the resources, and it says all these resources together, they constitute an app. So it groups them, and then I can inspect the app and see all the resources that are there. I can do a smart diff when I apply something new. It waits for my resources to converge, and then I can do custom waiting rules if I want, and it does resource versioning. So let's take a look at that. So the kubectl, let's delete those files. And then I'm going to apply them, but this time apply them with cap. So cap, the verb is deploy. And I'm going to deploy an app called Cloud Native. And then the input comes from standard in, and I'm going to say yes, so it doesn't give me a prompt. And here you can say we're waiting on the deployment to reconcile. So I have a little bit of feedback, and if it goes wrong, I don't have to go and look at my cluster to see, oh, shit, this hasn't, oh, oops, sorry, poop, this has not reconciled. Carvel or cap gives me, a little bit of info. It's going to tell me what it's going to do. I can inspect, so I can cap list to see the apps. Here's this one is our Cloud Native app, and so I can cap inspect the app that's called Cloud Native, right? So I see all the resources that are created for it. I can see them in tree, and then I can delete it by hand if I want. One of the interesting things, too, with cap is it can version resources. So what is that useful? Is you tell it this, instead of updating a resource in place, create me a new version every time. This is useful, for example, when you have config maps in a deployment. So our app is running here, right? And if I go and change my values to have the strawberries here and to have a nice emoji, strawberry, right? And I apply this with cap, it just changes the config map, but the deployment doesn't roll out because it doesn't know it has to roll out, just the config map was updated. So with cap, I can go and add an annotation on my object to tell it, well, this one is version. Create me a version every time this changes. So cap.k14s.io, versioned, right, like this. And so if I reapply the same application here, you'll see it deletes my normal config maps. I can tell it to keep them if I want, and then it creates versions of these config maps. And it updates the deployments to use those versions. So now, like for example, we can take a look at the strawberries have been re-rolled, of course, but like we can take a look at the apples. And if I change the values and I look for the apples one, apples here, apple here, I add my emoji, and I reapply my declaration with cap. It knows my config map is version, so it creates a new version, and it updates the deployment to use that new version. And so now I have an apple that's a nice emoji, right? OK. So these are the most useful tools for any workflow, right? Instead of when you're prototyping on Kubernetes, instead of running kubectl, you use cap, and then you can list, you can see what you've deployed, how you've deployed them together. YTT, you can use it, you can have a Helm chart, and then you can Helm template it, and then you can pass YTT after that to change it. Or you can generate customizations with for loops in YTT and apply those customizations after. So let's look at a slightly more involved example using those. So we're going to say that we have an existing application and we want to change it. So basically what Kustomize does. So I'm going to do this. Right, slash fine, and then next. And in here, we're going to be using YTT's overlay capabilities to change things. So we're going to write an overlay file, which is just a YAML file. And then again, with what we did before, we're going to ls overlay. Every time overlay changes, run that command, clear, and then ytt-f of application app, and then overlay.yaml here, right? So, oh, I haven't run enter, my bad. Oop, there we go. So every time it changes, it will change that. So what can I do with overlay? So overlay is a YTT module. This one. I load it to use it. YTT overlay. I'm going to call it overlay, so it's very clear what it does. And so it can select documents. So say I want to match by overlay.subset. I want a subset of the documents that I find here, and I want the kind, say, config map, right? And then for those, you're going to add me, say, maybe change the API version to be v1 Daniel 1, because it's a very convenient version of config maps. So if I do this and I run this, YTT is unhappy because it tells me, oh, I found 3 config maps, but by default I only expect 1. So expect, and I could do 3, or I can say 1 plus, right? And then it's going to change my config maps and my config maps only to have the v1 Daniel 1 famous version, right? And this is a program, right? So I can extract this overlay to this, and then I can do a variable, for example. So this is config map equals this by config map, right? So this one still works. And then I could say, oh, also find me a overlay match by overlay.not. So the opposite of config maps. And then you're going to do me an overlay remove. All right. There you go. And then here, of course, expects 1 plus, expects 1 plus, because I have many resources, and now I only have my famous v1 Daniel1 config maps left, right? So this is, again, this is a toy example, and if I want to show you how a real overlay looks like, I am going to show you my app first. So I'm going to modify my existing app. If you remember in the application values, each of the, oops, not this one, values.yaml. This one, each of the app was either public or not public. So in here, in the app, I'm going to only get the config maps for the applications that are public, and the other won't get, or that are not public, and the others, they won't get their deployments or anything. And then what I want to do is protect these others by putting SSO in front of it, because I'm an SSO guy. So with YTT, I can take an existing app. So here's like a more complicated involved deployment. So I use OAuth2 proxy to do OAuth2, and then an OpenID provider called Dex. And this OAuth2 proxy has a config map with its config inside. So in here, we could look at it, infra OAuth2 proxy. So it's just a deployment. It uses a OAuth2 proxy image, and it has this config map with strings, right? It's a big string. And I want to change this. So I want to change my deployment in 2 ways. I want to mount all of my config maps in the deployment, so the private ones. And then I want to edit the config to not serve this 202. Because this one is just a placeholder when I log in. I want it to serve my real things. So a real overlay would look like this. It's an app private here, OAuth2 proxy overlay. So I can do some logic. I can say, oh, only generate these changes for the apps that are private, they're not public. So if someone passes me data values, I will use that in the overlay to mount more volumes. Find me the deployment that is called OAuth2 proxy. And then for that deployment, you're going to add me the config map in the volumes, and then mount these config maps at this path, static file dir, which is like var static, this one. And then for the config map that contains the configuration for OAuth2 proxy, it's a big string, right? And so find it, and then find the key that's called OAuth2 proxy.cfg, and then apply a function. And that function here is going to read the existing value, and then it's going to use the existing line if it's right, and then otherwise it's going to replace the upstreams equals blah 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 by the line I want, right? So I can do pretty advanced stuff. I can do regex matching and replacement, for example. And so when I apply my thing here, so this time I do application, and I can apply everything because I have app infra, and app private here. So I'm going to apply everything. And so when it does this, it does change my upstreams value in my config by modifying the string, and then it mounts my bananas and apples. So I can do YTT of this, and then let's put the emojis back, because emojis are really important. Data values file, other resources, my custom values, and then cap deploy app called cloud native, if I remember correctly. Yes, and it comes from standard N. So in here, it's going to delete the deployment ingress service for the apples, because it's private, for the bananas, but not for the strawberries, because the strawberries is public. Then it's going to deploy all of this. It waits a little bit until my deployments reconcile. So now the apples are gone. The strawberries should still be around if my overlay is correct. And if I go to private, maybe in a private window, then I have to log in with OAuth2 proxy index. So a very secure password that is totally not password. And then I have my apples and my bananas here. All right? Sound good? Are we on time? 24 minutes. We're... Whew. OK. So YTT, template, patch, cap, deploy, and then you can see the nice things. And I haven't shown everything. YTT, if you want to learn how to use it, because it's kind of a complicated language at first, right? it looks strange. You can go to the website, carvel.dev/YTT. You scroll down the page, and you have a bunch of demos here. So, like here's how you load a module and you do base64 encoding. Here's how you use variables, a full demo. And then in here, I can, it's a playground, and I can change and say I'm going to add a name third here. And so it It shows on the right the output of YTT. If you're worried about privacy and you don't want to be running this on the YTT website, you can run the command called YTT website, and then I'm going to put on a port that's free, and so it can run on localhost as well, right? And so you have immediate feedback of your YTT without having to write my funky deployments that I did earlier, or enter commands, right? Okay, so we have an app, and I have no voice. 1, 2, 1, 2. Voice is coming back. Whoa, not great. We'll see. Okay, so we have an app. We can deploy it, but it's very, the cap thing, it's very much a toy, right? It's kubectl and deploy by hand. So before I deploy it, I want to make it a little bit more prod ready. I want to know what I'm deploying, and then I want to be able to distribute it, to give it to people. So 2 tools for this. One, these images that I have here, Bitnami, Nginx 125.2, I trust Bitnami to not change their tags too often if I take a specific enough tag. But maybe I want to be very strict in what I deploy, and I want the specific SHA of that image. I want that version here deployed. So I do that with kbuild. Kbuild takes any YAML document as an input. So for example, this, it can take foobar. It doesn't care that it's a deployment, that it's a pod, that it's my shopping list. It will look for the image value, and then it will, or the image key, and then it will resolve the value. So if we look at this and we run it, we can still do YTT-f of application. And then from here, I can pass this into kbuild-f, right? Take thing from standard in. And it takes a little while because we have to talk to the mothership, Docker IO. And then in here, if I go to my deployments, they've been replaced, right? So it has swapped the value for the resolved value at the time I run kbuild. And it gives me a little bit of annotations, right? It adds annotation and it says, I resolved your tag 740 and I found it at this URL, right? So I have information on how it found this. If I want to distribute my manifests with the specific versions that I know, rather than putting them in a manifest, I can generate a log file. So kbuild has this image package log output, and then we're going to put in log.yaml. So again, contacts the mothership because maybe the tags have changed. There we go. And now we have a log.yaml file, right? And it has the metadata of all the images it found. And it says, oh, you use Bitnami dex 2370, and it resolved to this, right? And so I can distribute this along with my app. And so when someone wants to run kbuild and have the image resolution that I had when I built it, they can also pass this log file in. And now it's instant, because I don't need to contact the mothership. The resources are all here, and it uses that log file, right? Kbuild can also orchestrate builds with Docker files and pack, but that's a more custom workflow. So this file here, usually we put it in application, special directory, image package, right? No, wrong, image package, but I want this to have a dot in front. Dot image package, there we go. And then so we move our log.yaml to application dot image packet images.yaml, right? Why is that? It's because we can use it with image package. Image package is the FTP of the future. It's the tar and FTP of the future, right? You remember 20 years ago, you used to FTP files over to a server, right, using FTP, FileZilla, or whatever. Then you had Git, right, and you could do GitOps, right? But one of the things with GitOps is that, well, if it's in a private registry or in a private repository, then I have to put credentials for that repository in my cluster. I already have credentials for a registry in my cluster. So the new thing with YTT is registry ops. So rather than putting your files in a Git repository and pulling them from Git, you will make a OCI image with one layer and your files inside and push them, and so they can be pulled from a cluster or from wherever. So in here, let's stash this, move on, so I don't do big mistakes. Cool. Wait, which one is that one? Kbuild. So next again. There we go. And so with this, I can run image package push, and I'm going to make a bundle. It's the name of the image package, the OCI image. I'm going to push it to a public repository, Carvel demo / cloud native day, right? And then the file that it takes are all in application. So image package takes this directory, finds all the images, makes an OCI images, and pushes it to Docker.io. So now, in here, I have nothing in my sleeve. I can, not Docker, image package pool, the bundle that's called Docker.io, de Garnier 963, Carvel demo CND, right? And the output is going to be, I'm going to put it in the out directory, and it pulls my image, right? So, or my image with my files in them. So it's not a runnable image. So if I tree the output directory here, ta-da, these things have gone to Docker Hub and then back on my machine. So they would be very easy to pull within a cluster without having Git. OK, so how are we on time? 30 minutes. Really? 30 minutes? OK, cool. So there's another thing with image package, but it's a very specific workflow that not everyone is interested. Does anyone here care about air-gapped environments? One hand, two hands. Ooh, OK, some hands. All right, so image package works well with air-gapped environments. So it can take files, make a tarball, push it to a repository, or registry, sorry. It can also, so you can push that bundle to that bundle of files to a private registry. But image package is also smart enough to find, if you remember, the application.imagepackage directory, and it can find the images file in here. And if it finds an image file in here and say, ooh, it means your application depends on these images, I'm going to take them and I'm going to copy them over for you. So, and relocate them to a new home. So it can do image package copy, and it's going to copy a bundle that's online. So Docker.io, de Garnier 963, we're getting there. Carvel demo, CND was the tag, right? And then you can push it to a repo. So I have this GCR.io repository, call it, what's it called? CF identity service oak and de Garnier. And then I'm going to call it Carvel demo. So image package pulls the bundle that it finds online, and then it unpacks it, and then it's going to look at these images here. And it says, oh, OK, I know these things, and then I'm going to copy them over for you, like 150 megs. Oh, it's actually, I didn't expect to be able to do this on the conference Wi-Fi. All right. All right. Yes. OK, it's done. It uploads all the images, then it uploads the bundle, and then tagging images. Cool. So I could go to the website and show them to you, or I can pull. I'm going to copy that one because it's kind of long. This one here. This one. And then in here in TMP, I can do image package pull the bundle that is this one with a TMP tag, and then the out is going to be copied. I'm going to put it in the copy directory, output. And so it pulls only here, it only pulls the bundle. It doesn't pull the images, so my files. But it has changed something in the copy directory. If I go to .imagepackage images in here, you can see it has retagged my images. So instead of being Docker.io bitnami dex, it's now in the same repository, so in Carvel demo here, but with a different SHA. And so now with kbuild, I can apply kbuild on my private cluster, and what we'll find when someone requests bitnami dex 2370, it will use that one that has been pushed to a private registry. So you can do with a machine that's connected to both registries, or you can make a tarball that goes into a USB key that you give to a soldier that will go to the Defense Department super secret data center, plug it in, and then so on, right? Maybe burn a DVD. I don't know. I don't know what they do. All right, cool. OK, so now, last bit, GitOps and package management. because it goes all the way to deploying. Here, so far, we've been deploying with cap manually. Carvel has a tool called cap controller, which is a controller you deploy to your cluster that uses cap to deploy applications. All right, so let's take a look at what this does. Maybe show it here. So its view of GitOps is that you need to define 4 things. You need to define what you want to deploy in terms of like, where are my manifests? Where do they live? So how do I fetch them? Using Git, using HTTP, using FTP if I want. How to template them. So what rules do I apply to change them? How to deploy them. Like which tool do I use to deploy them? Do I use kubectl, for example? And then what's the target? The target can be another cluster, so you have your GitOps cluster, and then you're targeting other clusters and deploying from your GitOps cluster. Or if you want, you can deploy in the same cluster, but then you need to tone the permissions down. So cap controller, when it deploys an app, it uses a service account with limited permissions per application. So I give my developer a namespace. It has a service account that can do certain things in that namespace. If they deploy an app, cap controller will use their service account. And so they can't deploy to the prod namespace if they're not allowed. The resources, it's called an app, and it looks like this. So you define your target, either a cluster, and you pass it a reference to a secret that has a kubeconfig in it, a service account name, which must be in the same namespace as the app. This is how we do privilege, how we constrain privileges. Then we tell it how we fetch our files. So we can fetch them, we can write the files inline as YAML. We can pull them from a Git repository. We can pull them from a Helm chart repository. So it supports Helm, and it works well with Helm. It can also use an image package bundle. So it can do registry operations. If I don't want to have Git credentials, I can use that, and it will use the registry credentials I have in my cluster. And of course, I can call several of them, right? I can mix. I can say I have my config in Git, and then I have my my manifests in an image package bundle. Then how do you template them? Of course, YTT, because Carvel is built to work well together. You can apply kbuild if you want locked images, as we've shown. You can also apply Helm templates. We're fine with this. It's OK. Helm is good. We like the product. You can apply Q, and then for signing, you can use SOPs. For deployment, we only love ourselves. We use cap. After all, it's called cap controller, but it's still possible to have something else in the future. So if we look at what this looks like in real life, so I think I still have my cloud native app here, right? So I'm going to cap delete the app called cloud native. Yes, so it shows me everything that it's going to delete, and then it waits a little bit. It wants the things to be actually gone to tell me, yeah, I've successfully deleted everything. And then we want to apply an app. So my app is in other resources, app.yaml. So in here, this is a cap controller app. I use a service account name, overprivileged, don't do this. And then I pull some files from Git. So first, I pull the manifests from the repository for this demo on the demo branch. And it's going to take everything that's under demo application, put it in the bundle directory for further steps to consume. And then on the same repo, I have a GitOps branch with YTT values. And so it's going to pull this file, this data values file, and put it in the Git directory. I could also pull an image package bundle, but I haven't loaded my registry credentials in here, so rate limits, so on. Then second step is template. So how do I template? I'm just going to apply YTT. We could apply multiple things, like Helm, then YTT if we want. So I'm going to template these 3 files, and then I'm going to load some values. And I can load the values from a path. So from this Git directory that we created here with my GitOps file, I can also have secrets that live in my cluster with my configuration if I want. Then I'm going to use kbuild to resolve the images. And then to deploy, I'm just going to use cap. And then I could write a complicated cap config if I have rules and my apps are not very, how would you say it, not very eventually consistent. They need to be ordered, then I could write this here. And so I deploy it with cap, of course. Cap deploy. The app is going to be called cloud native app, right? And the file is other resources. No, it's called app. And then this one, there we go, should reconcile. So if I go here, I look for the apps. So my full app is reconciling, so it needs to pull 2 Git repositories and then apply some deployments. So if I look at the deployments, they should be coming up, right? Well, proxy is big, so it takes a little while. Boom, boom, boom. And then after a while, this one is OK. And if I go back to the apps, it has reconciled. But this is very low level. This is for GitOps for operators. As a developer, I'm going to delete that cloud native app. Yeah, fine. Delete everything. As a developer, I don't really like consuming this. I like more higher level abstractions. And so what cap allows you to do is to define a thing called a package, and even package repositories. And so if I want to provide packages to my developers, they don't have to write custom resources. They could write a package, or they can use the kcontrol command line, which is designed to talk to cap controller. And with this, I can do kcontrol package available list. And then here it tells me that I have this package pre-installed on my cluster. I can get, so Carvel demo, it's called -p, Carvel demo.garnier.wf, right? It has a version 1.0.0, and so with this, I can even ask it for the values schema. So as a developer, I can look at how I can configure it. And so as a developer, I can kcontrol package install the package. Carvel demo Garnier WF version is 1.0.0. What else do I need? I need an installation name, so CND, for example. And then I can pass it data values from my other resources, my custom values here. Oh, data values file, sorry. From here. No. I'm getting it wrong. Values file, there we go. Oh, and of course, I'm deploying to default, which is a very good idea. You should totally do that in production. It's such a good idea that cap controller is yelling at me for doing that. And so this is how we deploy the Tanzu application platform, for example. OK, we are at time. We started a few seconds earlier, so I'm going to allow myself to give you a QR code for this demo. So you can, if you want to see those files and you want to go back on your own speed, read the things. There's a README that explains how these files are built and what's in there. So you can take that. Taking a second for the picture. Yep. There we go. And then with that, I thank you very much. Thank you for your passion. Here's a feedback form. It takes literally 5 seconds. If you leave me a text comment, it takes 20 seconds, and you have all my gratitude. Thank you for your attention. Oh, and questions, I think we're out of time, so questions in the hallway, at the party, whenever, it'd be a pleasure.
Thank you very much, Daniel. I think we might have time for one short question, and then we have to head down to the closing session and the keynote. Does anyone have? It's just first come, first served, obviously.
How does it do it? With Garnier, of course.
If not, oh yes, Mark. I'll try not to injure anyone here. So.
Wow, very good throw.
So, short question about cap. You said you can version
yes.
the files.
Yes.
Can you also delete the old versions?
Yes, so it deletes the old version for you unless you tell it to keep them.
Okay, and if you tell them to keep them, to do a rollback at a later stage, you can delete all your mess which you have with Kustomize?
Yes.
Very good.
Cool, thank you.
Thank you.
I think with that